Hey guys, in this video we're going to be going over lesson 5.7, which is on imaginary numbers. So if we have an equation like x squared plus 1 equals 0, that's going to have no real solution. If you go to your calculator and you try to solve that, you subtract a 1 from both sides and then you try to take the square root. So in your calculator, the square root of -1 is going to give you an error. There's nothing that you can multiply by itself to get a negative number. And so that's where imaginary numbers come in. So you need to know, you need to have memorized that I is the square root of -1 and I squared is -1. So anytime we have the square root of -1, that's I. So we're going to do some radicals but with negatives. So for example, if we have the square root of -9, well, you can't take that. You can't find that. So what we're going to do is we're going to take out the -1. And so when I divide that by -1, I'm left with 9, a positive 9. We know that the square root of -1 is I, because I just told you that. And the square root of 9 is plus or minus 3. Now I need to combine these. So we write it plus or minus 3i. Whenever you're writing your answers, you always put the plus or minus first. Then if you have just a regular number, you put that. Then if you have I, and then if you have a square root. That's kind of the order that you would write them. You don't write I3, you write 3i. Okay. The next one is square root of -196. So I'm going to take out the -1, and then I'm left with positive 196. We know that the square root of -1 is I. And the square root of 196 is 14. Plus or minus 14, really. So my answer is plus or minus 14i. Next one, we have square root of -5. So take out the square root of -1. That leaves us with a positive 5. We know that the square root of -1 is I. And 5 is not a perfect square, but there's actually no perfect squares that will divide evenly into 5. So we just leave it. So when I write my final answer, plus or minus, I didn't have just a regular number. I just had I radical 5. The reason we don't put the I last is that a lot of you would write that, and it looks like the I is under the square root. So the square root needs to be the very last thing that you write down. Number 4, square root of -1, square root of 80. Now, the square root of -1 we know is I, but the square root of 80, that is not a perfect square. So we've got to figure out what the largest perfect square is that goes into 80. So take 80 divided by 49. No. 80 divided by 36. No. 80 divided by 25. No. 80 divided by 16 is 5. So 16 and 5. So we know the square root of 16 is plus or minus 4, and then we have square root of 5. So when I write my final answer, plus or minus the 4 first, then the I, then the radical 5. Number 5, take out the negative 1, left with 32. Got to figure out what square root of 32 is. So look for the largest perfect square that goes into 32. And you get 16. Square root of 16 is plus or minus 4. And then we have square root of 2. So my final answer, plus or minus the 4, have I, square root of negative 1 is I, and then radical 2. And number 6, take out the negative 1. We're left with 192. Okay, we're going to divide that by all the perfect squares. So 192, hundred's not going to go in there. 81, nope. 192 divided by 64, that is 3. So 64 and 3. I know the square root of 64 is plus or minus 8. Then we have square root of 3, and we have I. So my final answer, plus or minus 8I radical 3. So now we're going to kind of use that to find the x-intercepts of some of these quadratics. So x squared plus 81 equals 0. I need to subtract 81 from both sides. That gives me x squared equals negative 81. And then taking the square root, x equals plus or minus 9i. If you can do it in your head without having to break it down into square root of negative 1, that's okay. You can just write 9i. Number 8, subtract 9 from both sides. 2x squared equals negative 8. And then divide by 2. X squared equals negative 4. Take the square root. X equals plus or minus 2i. Number 9, subtract 15 from both sides. 4x squared equals negative 16. Divide by 4. X squared equals negative 4. Take the square root. X equals plus or minus 2i. And number 10, subtract 13 from both sides. We get x squared equals negative 12. Take the square root. Unfortunately, 12 is not a perfect square. So we got to take out the negative 1. We're left with 12. That breaks down to 4 and 3. So x equals, square root of 4 is plus or minus 2. Then we have I radical 3. Now something else that you will be asked to do is to simplify powers of I. And before we get into that, I want to remind you of some of the exponent rules. So if I have x squared times x to the fifth, when you're just multiplying variables, you add the exponents, 2 plus 5, x to the seventh. But if I have x squared to the fifth power, you multiply x to the 2 times 5, which is x to the 10th power. That's something you're going to need for these types of problems where I give you I to some random power and you have to simplify that. So for example, we know that I is the square root of negative 1. That's all that I is. I squared, I told you that was negative 1. Those are kind of the two that you have to have memorized. Now from here, we are going to use exponent rules to simplify. So I cubed, that would be I squared times I to the first power, right? Because I squared times I to the first is I cubed. And since I squared is negative 1, I to the first is just I, that would be negative I. I to the fourth, that would be I squared times I squared. I squared times I squared is I to the fourth. 2 plus 2 is 4. And I squared is negative 1. So negative 1 times negative 1 is positive 1. So I to the fourth is 1. If you have I to any power, it will simplify to one of these four things. It'll either be I, negative 1, negative I, or positive 1. So you always have a 25% chance of getting it right. If it's an odd if your exponent is an odd number, it'll always be either I or negative I. If it's an even number exponent, it'll either be 1 or negative 1. Okay, so I to the fifth. Once we start getting up a little higher, you can always follow this same pattern. So actually, let's do the even ones first. So I to the sixth. We can always do I squared in parentheses and then raise that to some other power. And that power would have to be 3. Because 2 times 3 is 6. So that's the same thing as having negative 1 to the third power, which is negative 1. If we go down to I to the eighth, we put I squared in parentheses. We would raise that to the fourth power, because 2 times 4 is 8. So that would be negative 1 to the fourth power, which is a positive 1. So anytime that you have an even exponent, you can kind of do it this way, where you put the I squared in parentheses and then you raise that to some power. Now, if it's an odd exponent, you can't really do that because I can't take 2 times some number to give me 5. But what I can do is I can take out one of the i's, leaving me with I to the fourth. Okay, so that's I. Now we have the even exponent. I can do I squared squared. I squared is negative 1 squared. So I times negative 1 squared would be a positive I. I know this is really confusing, and you just kind of have to memorize the steps, the pattern. And we can do more examples in class if you need them. All right, now I to the 7th. Take out an I. We're left with I to the 6th. So I can change that I to the 6th. I can do I squared to the 3rd power. That would be -1 to the 3rd power. So -1 to the 3rd power is -1 times I is -I. So let's do some examples of just some bigger numbers. If your exponent is odd, you have to take out one of the i's. So we took out I. We're left with I to the 14th power. That I to the 14th power can be broken down. Let's just carry that down. This would be I squared to the 7th power, because 2 times 7 is 14. We know that I squared is -1. So that's really -1 to the 7th power. -1 to the 7th power is -1. So this is really I times -1, which is -I. Now number 12, because the 62 is already even, you don't have to take out one of the i's. The whole purpose of taking out one of the i's is so that you get an even number. So this one, we can already just do I squared to some power. That would be 31. 2 times 31 is 62. I squared is -1 to the 31st power. And that's going to be -1. So that's our answer. All right, last thing. When we multiply, it's just like variables. 4i times 7i is 28i squared. But we can simplify I squared. We know that I squared is -1. So this is -28. Number 14, when I multiply all of those, I have -4 times 2 times -9, which is 72i cubed. And we know that I cubed, if we look back, I cubed is -I. So my answer is -72i. Number 15, 2i cubed. Well, 2 cubed is 8. Then we have I cubed times 5i. That's 40 I to the 4th. And we know that I to the 4th, if we look back, is 1. So 40. Number 16, I radical 3 squared. Well, that's I squared. If I do square root of 3 times square root of 3, it's 3. Times -8 squared is 64. Then we have I squared. 3 times 64 is 192. And then we have I to the fourth. I squared times I squared is I to the fourth. We know that I to the fourth is 1. So 192 is the final answer. I'm sure that you may have questions on these. That's fine. If I, for some reason, don't go back and ask for questions in class next time you're in class, please speak up and ask. I don't care at all to go over some of these. But if you don't ask, I may assume that you already got it. So please ask, email me, whatever. And if you don't have any questions immediately, have a good day.